Welcome to section 5.1 here, slope fields, day 2 for section 5.1. We're going to talk about slope fields, and slope fields is a graph, a graphical form or a graphical representation of a differential equation of the slopes. So what we do is we have a bunch of points, so we have a bunch of coordinates, as you can see here, and the ones you do on the exam are not going to be this much. But what we're going to do is we're going to take each of these points and we're going to find the slope that would correlate to each of these points, given a differential equation. Being that there are so many of these points, we're going to be able to find some commonalities between our points. And then what we're going to do is we're going to draw a nice short line segment through that point that correlates to the slope. It doesn't have to be exact, but things that are common should be exact. And we'll talk about that here in a little bit. So let's go ahead and get started. And we're going to create a slope field for this differential equation, x squared plus 1. So we know dy dx equals that. We know that this is the slope, right? Dy dx is our slope. That's our derivative. So what it's asking us to do is to go ahead and find the slopes at all these given points. Well, if we think about, let's just pick a point here, 1, 1. So what that tells me to do is go ahead and plug in 1 for x and 1 for y. If I plug in 1 for x, I get x squared, which is 1 plus 1. That gives me a slope of 2. So what I want to do is to draw in a slope of 2. Well, how do I know what a slope of 2 looks like? Well, if I come up here, and here's my point, I know a slope of 1 is a perfect diagonal, isn't it? We call it a perfect diagonal. A 45-degree angle with the origin. So the slope of 2 would probably be a little steeper than that. So I come over here to 1, 1, and I'm going to give it a steeper slope than 1. Well, if I come up to my next point, which is 1, 2, again, or I guess not again, but if I look at my equation, I only have x's in them. So that y value is not going to change. So that's a commonality. We call it a commonality with this. So if I plug in 1, 2, I still get a slope of 2. So the slope at 1, 2 is going to be equal to the same slope of 1, 1. So I know that this line segment, they're going to be parallel to each other. And I'm going to make these two equations, or these 2 points, very parallel. As I work my way up, that's going to be parallel as well, isn't it? So I should have nice parallel lines. Whenever x equals 1, it's going to be the same value. If I can make them parallel today, I don't know why they're not going parallel for me. All right. Also, I'm going to jump over here to -1. And doesn't matter what my y values are, because there are no y values in my differential equation. But I know that when -1 is plugged in, I know that the slopes here at -1 are going to be the same as that 1. So again, a commonality, these slopes should look very similar to each other. I don't know why my pen won't make them parallel to each other. All right, so that's what's going to happen with my -1 and my 1s. Let's think about 0. When x equals 0, well, I have 0 plus 1, that gives me a slope of 1. So that's going to be a nice diagonal, isn't it? So I'm going to have my nice diagonal in there. So notice now my slopes here are definitely less than here. So as I'm looking at that, I can say, oh yeah, he meant, or they meant, that this slope here was not as much as this slope here. As I work over to 2 squared plus 1, well, that's going to be 5, isn't it? So this slope is going to be much more than this slope here. So again, I don't necessarily know what a slope of 5 is supposed to look like, but I know that all of these x values are going to be the same. So all these lines should be fairly parallel, and they should be more steep than these lines here. As well as this -2, I know that these are going to be parallel to these, and they're going to be more steep than the 2s, or the 1s. As I work my way over, what's going to happen? Well, now I've got 3. Now I've got 3 squared, which is 9 plus 1 is 10. So now that's going to be fairly steep. So I'm getting pretty steep here. And again, these are going to be very similar to them. And as I work my way over, now once I get to 4, I get a slope of 17. That's getting a little ridiculous if you ask me. Who gave us this problem? So as long as our slopes are getting more steep, notice these are more steep than these, and as I work my way over, I'm almost going to have a vertical line at that point. But notice with all my points, I don't connect any of my points. All I'm doing is drawing a short little line segment through that dot. Right? Now, as you look at this, though, it's kind of neat to see this come about, because you can kind of see that these points, they're coming up like this, and then they're coming out, and then they're coming back up, aren't they? And it doesn't matter where you are, it's kind of a nice flow with all of these points. So that's going to allow us to sketch a solution. Normally what they're going to ask you to do is to sketch a solution through a given point. Maybe 1, 1, or maybe 0, 0. So if they do ask you to sketch a solution through a given point, make sure you do go through that point. But here it's just asking you to sketch a solution. So to sketch a solution, we're just going to kind of follow kind of the grain of these slopes. So if we maybe start here, notice that kind of goes along with what our equation would be. So notice I didn't go through all of the points, and I didn't go through, I didn't make the slopes touch each other. Then they will somewhat. Actually, probably should go down more like that, shouldn't we? But we should see that this equation is a cubic function. In a cubic function, we have, if I go ahead and solve this, I get x to the third over 3 plus x plus c, don't I? So there is our nice cubic function. All right. Again, we're going to go ahead and do the same thing for the next one, dy dx equals 2x. So again, I'm going to go ahead and find some commonalities. Notice again, I don't have any y's, so they're all going to be parallel going vertically, up and down there. So if I plug in 0, 2 times 0, that's 0. So here, I have 0, don't I? And a 0 slope would be horizontal. Very important that those are nice horizontal lines. If I plug in 1, I get 2. So again, it's going to be a little more than a nice diagonal. If I think about my commonalities over here, I knew that 1 and negative 1 were the same. Well, here if I plug in negative 1, I get a negative 2. So they're going to be just the opposite of those. So again, they should all be parallel, fairly parallel here, and parallel through here. All right. Now if I plug in 2, I get 4. So again, more steep, if you wish. And coming over here to the negative, they're going to be mirrored with those values there. 3, even more steep. And it does get more difficult as our numbers get very large to probably get to these points. And we're going to go ahead and stop it as we get into the 4, because at 5, that's going to be a slope of 10. It's going to be very difficult to see. So it's going to be almost a vertical line there. All right, but notice again, we see that these lines are coming down, and they're kind of coming into that y-axis, and then they out of the y-axis they turn and they go back up. So a solution, if I want a solution here, it looks like they're kind of coming like this, and then down here they're kind of coming like this. And that would be a solution. And that looks very familiar to us, because if we integrate 2x again, if we integrate those, we end up with y equals x squared plus c. and that is our quadratic function. Now the last one I want to do with you is going to be this dy dx equals negative x over y. So here we have x and y changing. Oh, good gracious. So what's going to happen with this? Well, let's think about what happens with x and y. Let's come here to 1, 0. So if x is 1 and y is 0, what's happening with that? Well, we get negative 1 over 0. Maybe we'll even give you the point, negative 1 over 0. And negative 1 over 0, that's undefined, isn't it? And the slope of undefined is a vertical line. And now some commonalities with this. Whenever y is 0, I know it's undefined. So on the x-axis here, we get this. I'm going to skip over that 0, 0 here for a second. All right. Now, if we think about x being 0 and y not being 0, so anytime that y or x is 0 over a number, that gives us 0, doesn't it? So that's going to give us a horizontal line. Again, I'm going to skip over that 0, 0 just for a second. Now, what I need to do is pick some other points. So what happens at 1, 1? Well, I get negative 1 over 1. So negative 1, 1, 1 gives me negative 1 over 1, which is negative 1. So slope of negative 1 is a nice diagonal through that. And some commonalities here, if I go over here to negative 1, 1, that gives me a positive 1 slope. And at negative 1, negative 1, that gives me a negative 1 slope. And at 1, negative 1, again, gives me a positive slope. Now I can come up here to 1, 2, and that gives me, at 1, 2, that gives me a negative 1 half. So negative 1 half is not going to be as steep as that one. So it's going to be something like this. Jumping over here to 1, 2, that gives me a negative 1 half, so it's going to be similar to that one there. There we go. And then we can go ahead and jump down here and jump down here. Again, these are not going to be as steep as the one above it. Now I can jump over here to 2, 1. And at 2, 1, I get a negative 2 over 1, which is negative 2. So that slope is going to be a little more than that slope there. So as I work my way over, again, I can jump over here, some commonalities. Not going to be as steep, or it's going to be a little more steep than these here, in a positive direction, here in the negative direction, in the positive. And kind of neat how we kind of see what our graph is going to look like, doesn't it? Anybody see what maybe figure that we're starting to bring into play here? And the better you draw your slope field, the more it's going to pop out at you. So here, let's do another one here at 2, 2. So at 2, 2, that's going to give us a slope of negative 1 over 1 again. So it's, again, we're going to be back to here. And really, I guess we can do the commonalities here. At 3, 3, it's going to be the same, and 4, 4. And then these are all going to be the same as well. So nice slopes there, nice perfect diagonals. Put these in here. And as we work our way out, we know that these are going to be a little less here. And as we work our way down, so I know what this figure is going to look like. So as you put in your numbers, you're going to kind of see that they're all going to kind of work out. And I've got enough in there. You can fill out the rest of them if you want. But notice, here's the bigger picture of what I want you to see. Notice what we've got here. If we follow in those slopes, we have a circle, don't we? And if we think about dy dx equals negative xy, if we were to solve that differential, and we will be solving this differential later on, we'd have just y dy equals a negative x dx. So we get y squared over 2 equals a negative x squared over 2 plus c. And if I add that over, I could have x squared over 2 plus y squared over 2 equals c. If I multiply my 2 out, I get x squared plus y squared equals 2c, which is c. What do we know about that? That's the equation of a circle. So we do see that nice circle come into play. So that gives you an idea of slope fields. I do want to show you how to do this in the calculator as well, because we do have a program that will do it for us. Not that I want you to wholeheartedly do this with a calculator, because it will be a non-calculator question, probably. But we can type in any of these equations. We can do x squared plus 1. So if we just go, we first have to go to our y equals and type in that equation. So we have x squared plus 1. And then to get the slope field, we go to program, and we can do either 6 or 7. 6 is a little slower than 7, but they will both work. So you just run your program, hit enter there, and notice here is our slope field. And that should look, again, very similar to what we have here. So notice we come up, then we're coming out and coming in. So that gives you kind of an idea of what it looks like. Notice out here, it doesn't differentiate between the slopes out here at 4 and 5, because it's just too close to each other. Your negative x over y, we should be able to do that as well, if I remember how to do that. I believe we can just do our negative x, and then divide it by our y. We have to do our alpha, and then y. And then we can go ahead and go into our program, do our slope fields, number 7, and there it comes. So it's not as pretty because our windows here are stretched a little more, so it looks more oval on here, but it actually is, once you get onto a unit dimensions, it does get more circular for us. So that gives you an idea of slope fields and how to use them and how to put them in the calculator. Good luck, enjoy, and have fun.